So greetings, so welcome to today's class. So what we are going to look at today is a discussion on what is called as wheel alignment, okay, which is very important for vehicle performance, and that is something which is related to typically the steering and the suspension systems. So let us look at what this concept of wheel alignment is and what are the various parameters that are used to quantify wheel alignment. So the term wheel alignment in a broad sense, like is used to indicate or represent an important or a critical set of design and maintenance parameters. So as the vehicle is operated, so these parameters can change with time, and it is important to ensure that the parameters that we are going to learn be kept within the design limits. So we would see what happens if we do not do that, and these parameters have to be maintained in a specific design range to ensure good vehicle performance, particularly cornering performance and maximizing tire life. Okay. So because it is important that these parameters be maintained in a certain design range, to ensure that the vehicle performance, in particular its cornering performance. What do I mean by cornering performance? That is the response of a vehicle when it is taking a turn, right. So that is typically called as cornering, and even when the vehicle is going on a straight line, like straight path, there are going to be perturbations. Then the question becomes, how does the vehicle respond to the perturbations, like how does the driver get a feedback through the steering wheel, and what is the comfort level of the driver and its occupants, like all those are affected by these parameters. Okay, we are going to look at them. Okay. So these parameters have a direct impact on cornering, the so called straight line performance or straight line response. See, because sometimes like when we drive a car, like we would have observed or we would have felt that even if the driver holds the steering wheel in the centered position, the car may like drift towards one side or the other, right. So we are going to observe when such things can happen, right. What are the causes of such observed phenomena. So that is what comes under straight line performance. Okay. So it is very important to ensure that when the vehicle is driving straight ahead, and the driver gets good feel, and then the car does not deviate from its path, right. So it does not drift from the straight line path decided by the driver. And more importantly, like these wheel alignment parameters have a direct impact on tire wear. Like so tire is an important element in an automobile because all the forces that are transmitted to the vehicle and those which act at the tire rod that act on the vehicle to brake, to drive the vehicle, to steer the vehicle, right, are transmitted through the tire rod interface. So tire becomes very important, and if the wheel alignment is not proper, then we are going to have consequences as far as rapid tire wear is concerned. Okay. So what are some practical signs, you know, like of poor wheel alignment. Let us look at it, look at these first, and then like we would define various parameters very carefully, and then like we would correlate these observations that we see in practice. So, one sign is vehicle pulling to one side. So, even if the driver intends to go straight ahead, you know, one may feel that the vehicle is being pulled or it is drifting to one side. That is a sign of poor wheel alignment. If we look at the tire, if the tread of the tire, right, undergoes non-uniform or uneven wear, that is also a sign of poor wheel alignment. Later we are going to look at the wear pattern, and we are going to observe as to how the poor wheel alignment can result in uneven wear on the tread patterns. Okay. So, sometimes we can have what is called as uncentered steering, like what is called as uncentered steering. As we are going straight ahead, we have to essentially enable the driver to keep the steering wheel in its centered position. Okay. But sometimes in order to keep the vehicle going straight, like small steering input may need to be provided. Okay. So, that is what is called as uncentered steering, like, so that is something which is a sign of poor wheel alignment. Okay. So, steering wheel is off center when driving straight. Okay. And sometimes like if the wheel alignment is not proper, like we will also get steering wheel vibrations, okay, that are felt by the driver, right. So, which is also a sign of poor wheel alignment. Okay. So, these are the signs of poor wheel alignment. So, what are the various wheel alignment parameters? So, by and large, like there are some what are called primary wheel alignment parameters, and some what are called as secondary set of wheel alignment parameters. Generally, it is agreed upon that there are three important parameters, which are critical to quantify wheel alignment. Okay. So, the first one it is what is called as the camber. So, what is camber and how is it defined and what is its impact? So, let us look at this simple schematic. So, what is camber? So, camber is nothing but the angle made by the central wheel axis, right, wheel plane axis, with the vertical direction when you view the wheel from the front of the vehicle. Okay. So, that is what is called as camber. So, let us say this green dashed line is the vertical axis, this red dashed line indicates the central wheel plane. Okay. So, essentially it is the angle made by the central wheel plane, right, with the vertical axis when we view from the front of the vehicle. Okay. So, this is what is called as wheel camber. Okay. So, let me write down the definition. It is the angle made by the wheel or tire with the vertical direction when viewed from the front of the vehicle. Okay. So, that is what is called as camber. So, it is considered positive when the top portion of the wheel leans away from the vehicle body. So, we can see here that in this schematic is a representation of what is called as positive camber. So, you can observe that the top part of the wheel like is leaning away from the vehicle body. When the top part of the wheel is leaning closer to the vehicle body, towards the vehicle body, it is considered as negative camber. Okay. So, that is the sign convention. So, positive camber is one when the top of the wheel leans away from the vehicle body. Okay, that is positive camber. So, we encounter or we define negative camber as just the opposite. Okay. So, if the top of the wheel leans towards the vehicle body, okay. So, that is negative camber. So, why is this camber introduced in the first place? Like so typically if you look at most vehicles, like most cars, like where the front wheels are steered, you would observe that a small negative camber is introduced by design. Okay. Why is that? So, let me just convey that through a very simple schematic, right. So, suppose let us, I am drawing a very exaggerated diagram to just convey the point. Let us say these are my two front wheels, right, which are steered. Okay. So, we can immediately observe that they have very steep negative camber. Suppose let us say we are taking a turn towards this direction. Now, when we take a turn in this direction, what is going to happen to the vehicle? It is going to roll in this manner, right. So, always the vehicle will roll out of the turn, right. So, this will be the inner wheel and this will be the outer wheel. Now, with this higher negative camber, what is going to happen as the vehicle rolls outwards, this wheel will be almost made vertical, or it will just shift closer and closer towards the vertical axis, so that when the vehicle is taking a turn, there will be a good contact, like between the tire and the road interface. So, what this means is that we get a good grip, so called grip at the tire road interface when the vehicle is taking a turn with a small negative camber. This is also an advantage as far as the outer wheel is concerned, because this is the outer wheel, right, in this particular case. Why? Because this good contact at the tire rod interface is beneficial, because while taking a turn, there is always going to be lateral load transfer from the inner wheel to the outer wheel. Okay. So, load is going to be transferred always from the inner wheels to the outer wheels. So, it is important that the outer wheels get a good grip at the tire rod interface, the outer tires, so that sufficient lateral forces are generated. Okay. On the other hand, let us say we had positive camber, okay, instead of negative camber. I am just drawing the outer wheel alone, right. So, if we have an exaggerated positive camber of the outer wheel, what is going to happen if we take a turn, if we do the same exercise, the vehicle body is going to roll out, and then the outer wheel is going to, the positive camber on the outer wheel is going to even more increase. So, the grip of the corresponding tire is going to only weaken. Okay. So, for this reason a small negative camber is typically introduced. What is the price or trade off? We can immediately see that if we introduce a camber, a negative camber for example, we can immediately see that as the vehicle is going straight, the inner surfaces of these tires are going to wear out more than the outer surfaces. Of course, if you have excessive camber, right. So, that is the trade off. Okay. So, in order to balance both, like we essentially introduce a small negative camber, okay, at the wheels, at the steered wheels. So, in essence, a small introduction of a small negative camber ensures that when the vehicle is turning, taking a turn and the vehicle body rolls, the outer wheel like essentially becomes a little bit straight, right. It becomes straightened so that the contact at the tire rod interface is pretty good and we get a good grip, right, at the corresponding tire rod interface. What happens to the inner wheel like with negative camber, like if I have what to say a negative camber on the inner wheel, yes, the inner wheel is going to roll in this way, right. But is it going to be so bad as that of the outer wheel? There are mechanisms. When we come to suspension, we will see that like we have mechanisms by which we can adjust this, and also we want the outer wheel to have better grip because of the load transfer due to the roll motion. Okay. So, that is why a small negative camber is prescribed. Okay. So, these are various reasons, right. Okay. So, let me write down the reasons. Okay. So, a small negative camber is typically introduced such that when the car body or the vehicle body rolls during cornering, the tire becomes almost upright. Okay. So, just a very qualitative figurative usage, right. That is the negative camber decreases and becomes almost upright with roll, resulting in the best possible contact area at the tire rod interface. Okay. So, this implies that better grip during cornering. Okay. Let me put this word grip under quotes. Okay. We get a better grip during cornering the vehicle, right. And it becomes advantageous as we discussed with the outer wheel because of this dynamic load transfer while taking a turn, right, from the inner to the outer wheels. Now, if camber is out of adjustment, okay, it will cause wear on one side of the tire strand, okay, excessive wear, right. So, on one side of the tires, right. Okay. And if the camber is different from side to side, it would lead to pulling. So, what do we mean by different from side to side? If you take the same, let us say axle, so to speak, right. If you look at the right and the left wheels, if the camber is different, like that is going to what to say, create this pulling. So, we will see that when you go to vehicle dynamics, like if you learn vehicle dynamics, you will see that this camber is going to result in what is called as camber thrust, like which also helps in taking a turn, right. Okay. So, this is wheel camber. The second important parameter as far as wheel alignment is concerned is what is called as caster. So, what is caster? So, let us look at caster. So, for camber we looked at the vehicle from the front. So, now what we do is that like we go to the side of the vehicle and we look at the vehicle from the side. Okay. So, as we discussed when looking at steering components and steering systems, if you recall that the tie rod essentially went and was fixed at the steering arm, right, at what is called as the ball joint, right. So, let us say this upper ball joint is where typically the tie rod is fixed to the steering arm. There is something called as a lower ball joint, which we will come to when we look at suspensions, like depending on the type of suspension you may have a control arm or a wishbone where you will have what is called as a lower ball joint. Okay. Now, if we draw a line passing through these two ball joints, that is what is called as the, what to say, from this perspective, like it is the axis about which the wheel is going to be steered. Okay. So, when we draw a line through these two ball joints. So, what is caster? So, this is the steering axis. So, caster is nothing but the angle made by the steering axis with the vertical when we look at the vehicle from the side. Okay. So, that is the definition of this caster, right. So, caster is nothing but the angle made by the steering axis with the vertical direction when viewed from the side of the vehicle. Okay, so that is caster. So, what is the sign convention? So, what is being illustrated in this schematic is positive caster. Positive caster means the steering axis leans towards the rear of the vehicle as we go up. So, in this schematic we can see that as we go up from the ground, right, the steering axis is leaning towards the rear of the vehicle. Okay. So, that is positive caster. So, when will caster be negative? It is the other way around, right. So, when the steering axis leans towards the front of the vehicle. So, what is the impact of caster? Once again let me draw a very simple schematic and explain. So, suppose let us say a vehicle is taking a turn, right, and this front wheel is steered. So, say this is the longitudinal direction axis and let us say this is the orientation of the steered wheel. Okay. So, this is the wheel plane. Okay. So, since the vehicle is being steered in this way, okay, at the tire, right, road contact, there is going to be a lateral force Fy which is going to pull the vehicle into the turn. So, I am looking at the vehicle from the top, okay, I am considering only one of the two steered wheels. So, let us say like I have a vehicle and let us say it is taking a turn to the left, right, and so I am looking at the vehicle from the top. So, this it is turning this way, right, as indicated. So, there is going to be a lateral force at the tire rod interface which is going to pull the vehicle into the turn. Now, the steering axis will essentially create a moment, like so. If you project the steering axis now, what will happen is that like it will come and intersect the ground somewhere here, okay, ahead of the tire rod contact patch, okay. So, that is a result of this caster being positive. Now, the steering axis hitting the ground at this point. So, what will happen is that when this lateral force is generated at the tire rod interface, there is going to be a moment of this lateral force about this steering axis, is it not, okay. And what will this moment try to do? It will try to align the tire back to the longitudinal axis of the vehicle, okay. So, because this is the this is an axis parallel to the longitudinal axis of the vehicle, right. So, this is the wheel plane, right, or the wheel axis, right. So, the self aligning moment is going to rotate, it is going to have a tendency to rotate the tire and the wheel assembly and make it straight within quotes, right. So, this is what is called as self aligning torque or self aligning moment, and we would have observed this when we steer a vehicle, right. When we steer a car, right, and we take a turn, and now we want to come to the straight ahead path, right. What do? Do we turn the steering wheel back to the center? No, right. What happens? We just release our grip from the steering wheel, we will start accelerating, and then what happens? The self aligning moment will ensure that the steering wheel comes back to its centered position, okay. So, this distance is essentially what is called as a trail, okay. So, this trail times the, in a very simple manner, right. So, of course, we need to analyze it very carefully, right, but in a very from a very simple perspective, this trail times the lateral force will give us the magnitude of this self aligning torque, okay. So, that is basically the impact of this positive caster. So, we can immediately observe that a positive caster results in a trail that creates a self aligning torque. Okay. So, that is the impact of caster. However, like we do not want to make this caster as high as possible, right. So, that is too high, right. Why not? Because of course, we want certain amount of self aligning moment, but if we increase caster to a very large value, what is going to happen is that like the effort that the driver needs to put in to turn the steering wheel also increases, right, because the driver needs to overcome these moments, right. So, to steer the steered wheel, right. So, there is a trade off. High caster means like you will have, so a high caster results in better straight line performance, because any perturbation the steered wheel is not going to essentially turn that much, right. So, because of this higher trail, right. So, a high caster results in or improves straight line performance, which is good. So, why does it improve straight line performance? Because we have more stability due to higher self aligning torque but leads to higher steering effort, right. So, maneuverability takes a hit, right. So, that is the trade off, you know, like of having a high caster angle. So, we get lower maneuverability, okay, with high caster angle. So, there is a trade off once again, okay. So, and if caster is different from side to side, that is between the left and the right sides, right, it may result in pulling. So, that is the impact of caster.